Good morning, it's 10 o'clock. My name's Tom Manners, and you're watching the second of a series of five special sessions looking at the NCETM's 5 big ideas of teaching for mastery. We looked at variation last week, but as it says on this diagram here, there's plenty of connections between all the 5 big ideas, so I'm sure we'll refer back to it. But today, it's mathematical thinking, with one of my favorite quotations as a subtitle, "Memory is the residue of thought." And alongside me today, the brilliant, enthusiastic, more enthusiastic than me, and that takes a lot, Helen Hackett. Good morning.
Good morning. It's brilliant to be here again and to be able to talk about maths with like minds.
And do you know what's fun about you and I, Helen, because we've met a number of times now. We haven't talked a lot about this hour. We only met 10 minutes ago to make sure we're both working. This is working. But I know we can just chat about this because this is where almost the most interesting maths comes in, where you're really delving, and I just think we could, I'm pretty convinced we'll be able to just back and forth over this for the hour. I'm hoping anyway.
I'm sure. Exactly.
If you do know nothing about the Maths Hubs, now we aren't doing this on behalf of the Maths Hubs. We're doing this because we're passionate about maths, both Helen and I this morning, but we've both become more passionate by getting involved with our local Maths Hubs. And so I encourage you to please join the mailing list for your local hub. Go onto that website there, mathshubs.org.uk. Also, if you're interested in learning more about these, and I'll repeat this at the end of the hour, each hub is recruiting schools to be part of next year's research groups and to learn more about teaching for mastery. These hours that we're doing on the Friday mornings are really just an introduction to each of the 5 big ideas. Don't think that's everything. There's more to be learned from it. So do go along to your local maths hub and see if you can get involved in your school to get specialists supporting you and your school's development. So who am I? There's me, again, always pre-COVID. I might just have to do a new photo and accept that the beard is staying. I teach teachers at Arthur Terry Teaching School in the West Midlands. I love doing that because it keeps me up to date with research. But of course, I do work with the NCETM as a teaching for mastery specialist and as a work group lead and a PD lead. Helen's list of accolades absolutely exceed mine. Primary early years teacher, maths leader, leads maths across a small mat in the West Midlands. A teaching for mastery lead for the Central Maths Hub, a PD lead, an SLE, and a mathematics specialist teacher, maths consultant, working with all types of schools across the country. And of course, you went to Shanghai, Helen, as well.
Indeed.
And you used the expression when we were just talking before about the kind of questions that we work on and we work through. And I'll be really interested to delve into that in a few moments' time. So there are those 5 big ideas. I think it's really important that we talk about research in these sessions on a Friday morning, because these aren't just things that people have thrown together from the NCETM. There's the research behind it, and we'll certainly get to the EEF in just a few moments. But there is research behind why these 5 big ideas are all important. And they link very much to our 3 assessment objectives, which are the same for primary and secondary. And that's why when I'm doing these sessions, I'm being joined by a primary specialist as well, because as far as I'm concerned, Helen, back me up or tell me I'm wrong, is the maths any different?
No, it isn't. And in fact, when it comes to thinking mathematically, it starts off really, really well before children come to school. But if you don't get it right in the early years and in key stage 1, it can be really, really tricky to pick it up later on. So it's really important, the primary journey matching the secondary journey.
I've always been a big advocate of trying to be as consistent as we can through the years. And so, those are the same objectives. It's really, really true. The key messages from the NCETM and this big idea of mathematical thinking: it's central to deep and sustainable learning of maths. And that's why, I always go to this same little leaflet that's on my wall. Memory is the residue of thought. If the children have to think about it and work on each question, and through the question, look at the link between them, maybe they're more likely to engage with the questions, thought about them, and it's going to stick. It's not just performance. It's actually having to really think about it. Taught ideas that are understood deeply are not just received passively. They're worked on by the student. They're thought about, reasoned and discussed. A silent classroom is a suspicious classroom, I remember Yip Van Haar once saying. And I really like that one as well. And I actually do wonder, do you get many silent classrooms in primary, Helen?
Hopefully not now. I think a few years ago, maybe a few, especially in key stage 2, but hopefully not now. There are times when children will work quietly for a little while, independently, obviously, but especially at the beginning of a lesson, a lot of talk, a lot of back and forth discussion. Yeah.
And I always challenge secondary school to think about year 7. They're only a few months away from being year 6. And so that transition should be smooth. That transition, that kind of mathematical behaviors in the classrooms should be somewhat the same, or should be the same. And so when so many manipulatives are being used in year 6, why not in year 7? But we're doing manipulatives another week, so let's hold on. Mathematical thinking involves looking for pattern in order to discern structure. We'll investigate that in a little bit of time, I'm sure. Look for relationships and connecting ideas. That might be between questions, that might be between topics, which is incredibly important, certainly when we know more about cognitive load theory and how the brain works and stores memory. When we make connections to previous ideas, it is more likely to stick. And there's reasoning logically, explaining, conjecturing, proving, keywords that appear in our national curriculum as well. Again, I did want to make sure we covered quite a bit of the research supporting mathematical thinking. And mathematical thinking is concerned with ensuring pupils understand the mathematics and are able to reason with and discuss. That word understand actually means quite a lot, Helen, doesn't it?
It does, absolutely. And sometimes the focus can drift away from that to providing correct answers. And I know there's going to be a lot of fear about that come autumn when all the children are back in school, hopefully, about do we allow enough time for children to understand rather than focusing on sort of answering test questions.
It's all right. The government's announced this morning £1 billion, but everyone will catch up straight away. It won't be a problem. So it did. Great news this morning. At least a quarter of the mathematics GCSE now test pupils to reason, interpret and communicate mathematically. Now, of course, in primary, there's the reasoning papers as well. So what is the percentage actually for primary? How does that work?
I do worry sometimes about the titles of the test papers for the Key Stage 2 SATs, that you have an arithmetic paper and you have you have the 2 reasoning papers. Because actually I fear that people think you don't have to reason when you're doing arithmetic, and there's quite a lot of reasoning. If you use what you know to answer questions, there's a lot of those arithmetic questions where actually you don't have to work really hard and write down a procedure. But yeah, there's 2 papers on reasoning and the 1 paper, shorter paper on arithmetic. And it's kind of sort of 20-25% on the one and the rest on the others.
Okay, I mean that's what you just said about if you know something, then you know something else. And I know, again, when we prepared this just 10 minutes to 10 today, we both had the same ideas of some of the questions we want to show. So we've got some of those in a few moments' time. Now, this is something that's interesting, worth sharing, actually. As much as it doesn't support mathematical thinking, it does suggest to us that one of the reasons we really need to encourage our pupils to understand what they're doing, that poor maths skills are estimated to cost the UK economy between 6 and 33 billion annually. And of course, enhanced employment opportunities arise with high mathematics achievement, but not all children reach the level that they're capable of. And that word capable then starts making us think about ability, and how the language now that we're not using the word ability, because how can we judge someone's ability? We judge their current attainment, because everyone can learn maths with the right scaffolds. And Helen, I know I think you're one of the first people I've met who was really passionate about making sure we're using the right language.
Absolutely. I have a real phobia for some of the language that people use. And even when teaching for mastery, sometimes people swap a label for another label. You know, my rapid grasper group or my greater depth children, or I had a child come up to me a couple of weeks ago and say, oh, I'm a greater depth child. And I said, what does that mean? And he said, well, that means I'm better than all the other children. And I was like, oh, that's no. And
not that child's fault, is it?
Yeah, mathematically, he couldn't think mathematically. He was quite quick with his facts, but as far as making connections and applying them, he wasn't that great. But yeah, it can be quite sad.
I remember having not an argument, actually, because I was agreeing with the head teacher of a primary school, and we were talking about the performance with programs like Timetable Rockstars, which I'm a huge fan of, but you don't do it by itself. You do it alongside the idea of understanding, because there's nothing wrong with the quick recall. But some people argue against that, but that's not right. If we're talking 7 times 8 being the same as 8 times 7, 7 lots of 8, the relationship with division, for example, that's fine to be doing the other stuff as well. But using Timetables Rockstars by itself would be considered.
Yeah, you need to balance it out, don't you? You need to have the understanding and the practice to get the fact fluency, but you need a balance of both.
Yeah, and I know Bruno Reddy thinks exactly that as well. The founder of the brilliant app, really, it is very good. Research supporting mathematical thinking. Enrich offers some 5 steps, and there's a good link on their website looking at that from 2014. The 5 steps in expert reasoning progression from describing and explaining to convincing, justifying, improving. And of course, links to SCEMP, the relational understanding, what to do and why. The bottom line is really important, opposed to using rules without being able to justify them. I think that probably backs up what you were just saying, Helen.
Absolutely. And I think also with that work on Enrich, some people think that's got to be a progression that moves through a school and that some of the younger children can't do some of those things. But actually, the very youngest of children can reason and can think mathematically. But sometimes we squash it out of them because we don't recognise it or we don't encourage it.
Well, I go back to that previous line of a quiet classroom is a suspicious classroom. Reasoning is considered more important than knowledge of arithmetic when considering children's mathematics achievement. Nunes, that paper is a primary paper. And using reasoning in classrooms, encouraging conversations between teacher and pupil as well as pupil to pupil is key for abstracting mathematical concepts. And that's backed up in a couple of papers. A bit more. This way, of course, we are asked to teach for depth now. I use the expression depth for breadth. I think differentiation in the past would have been, new topic. So you were adding fractions of the same denominator, now do it with different denominators. But that's not the idea that the national curriculum is encouraging. That's not what we're trying to get. We're trying to get the understanding of depth, challenging with maybe empty box problems. Open Middle's a really good website, which I know I've spoken about in the previous video. Those idea of conceptual understanding and linking to the work on variation as well. Now, we're bound to talk a little bit about variation today because, in fact, we might want to go straight into that. We'll come back to the EF because let's do a little bit of maths and we'll go back to the EF research in a bit if we could do, Helen.
Yeah.
If I scroll down to, now I should have learned how to do stop share so you don't see me go through all these questions, but it's tough. I haven't bothered to learn how to do that. Looking at these questions, which are primary questions, yet in secondary we repeat them because we don't pay enough attention as to what's been learned in primary, and we need to make sure we do more of that. You were using the words before we came live, working on and working through. Can you talk through maybe this as an example, and then maybe there's an example you'd want to share afterwards as well?
Yeah, I think this is very much how the textbooks that are recommended by the DfE at the moment help and support teachers, because I think if we think back to old style textbooks and maybe some of the questions we used to set, the focus used to be very much on getting answers. I fear a little bit of that may have happened now with some home learning and what parents are doing with children, and that children were just looking at individual questions and trying to get through them as quickly as possible, but just working on each word separately and working out the answer, calculating the answer. Some children maybe would start further down the questions and say, oh, you don't need to do the first 2 or 3, you can start further down. Whereas with variation, you can actually, it's not about the answer's not the important thing. It's actually what you learn and how the questions are related to each other. So that actually, if you start at the first one and work your way through, by the time you get to the last question, or even, before you get to the last question, you will have done a lot of thinking and a lot of making connections that will enable you to be more fluent beyond that lesson, beyond the answers to those questions. But that requires careful design of the questions. It requires the teacher to know when to let the children go and explore it, when to bring them back together and unpick it, when to stop and look and highlight 2 or 3 and really, some children will notice the connection straight away, but other children won't. So it's the skill of knowing, how do I make sure all of these children are connecting these ideas? So if you look at those examples working on through there, it's looking at what's changing each time and what's staying the same. So if you work through looking at 1 and 2 and then looking at 3 and thinking that actually it's the learning that goes on between those questions, that by the time you get down to 9 and 10, it's going to really, really support you rather than going straight in at maybe question 8, 9 or 10. Hopefully, is that your understanding?
Yeah, and I also keep going back to the 5 big ideas and thinking about how this is variation with intelligent practice. But you imagine if you did this with representation, And so a bar model, so a third of the £12, and then two-thirds of 24. Now, each of those little blocks, if you like, will be worth twice as much. Now, one thing that I started to try and do is put R's next to certain questions, because if children haven't been yet coached to think about the links between the questions, when I put an R there, I say, right, reason your answer using previous answers. And with time, of course, I'm hoping they'll do that for all 10 questions, or however many it be. But it's just something that I've started to do to make them look at. So question 3 there. Oh, if I'm trying to find two-thirds of £24. Oh, if I've done the previous question, that's interesting. That should be able to help me. So it's a scaffold, hopefully it's a step towards getting it right, whereas you said there, working through the questions. But I think I might be getting this quote of yours wrong, though, so correct me. If you're working on each one individually or working through collectively, so when you use that expression, work on and work through, can you explain that a little bit further? Because I'm wondering if I'm confusing myself.
Do you want me to share a slide?
Yeah, let me stop sharing, please do.
Yeah, and I will pick up and share mine. Very.
We turn it to 10 to 10 just to practice that we can both share. And by the way, producer Alan, good morning. Haven't said hello to you yet. How rude of me. If anyone does on the YouTube, do pipe up.
I'm hoping you can see that slide now. Can you?
Sadly not.
No.
No, it worked before. No, we'll get there. God, give you a second.
Gosh,
Let's just admire your background while you're doing that. By the way, Helen.
All right, I'm gonna.
Superb, the 10 frame, the dominoes. Oh, here we go.
Yeah, hold on. Can you see it now?
We can now, yes.
Brilliant. So if you think about working through or working on the questions, so this is taken from John Mason, but this is the two difference. The student that's just finding the answers to questions, doing a few questions, going away, coming back, doing a few more. And the focus there is very much on just getting the answer. Mm-hmm. Whereas if they work on the questions, really think about them, and so working through is just ploughing through and trying to get the answers. And that can be done spread out during the day, a little bit more random. But working on them means you're thinking about them, you're really processing what's going on. I mean, there's a couple of sort of examples there, quite simple ones, where you look at the design of that and you think, is that going to encourage the children to work on them? Are those related to each other in any way? Or is that going to just encourage the children to race their way through and find the answers? And then a comparison there. Hopefully you can see there's a difference between the design of those two. And
how dare you put the bigger number second, Helen? How dare you confuse the children? How dare the order change?
But yeah, it's that idea that it's not just about producing quick right answers. It's about actually getting the children to think for themselves so that they can apply that, beyond what they've been doing.
I know we've spoken about it before, Helen, but that line at the top there, the answer is just the beginning. In schools I've worked with, I've often gone in and said, can that be our motto? As a maths department, the answer is just the beginning. Please don't think it's, as you said, working through the questions, just go. How did you get there? How did somebody else get there? Then comparing methods, which of course is fluency, which again is where the 5 big ideas all come together, which is really, really nice. There's loads we can be doing. Let's go back if we may. In fact, I'm not showing my screen now, so let me sort that out. Let's go back to the EEF document, because there are new research. It was a few months ago, wasn't it? We'll look at Key Stage 2 and 3 today. But if you are an early years or Key Stage 1 specialist, maybe you want to refer to that in a minute, Helen. But let's look at this one first and foremost. There are 8 recommendations made, and quite a few of these would be referring to mathematical thinking. And by the way, I just want to point out number 8, because it always stands out for me: supporting pupils to make a successful transition between primary and secondary. We can all be doing that. That's not the job of year 7 and year 6 teachers. That's everybody's job, by trying to be a bit more consistent in what we do. Which are the ones that stand out for you here in particular, certainly when it comes to mathematical thinking then?
Can I just ask, are you sharing your screen again, Tom?
I should be. Adam, can you see it?
Improving mathematics in Key Stage 2 and 3.
Yeah.
I can see it now. It's
okay, brilliant. Okay, so which ones, sorry, you were saying, which ones do you think are the ones that really go deep into mathematical thinking for you?
I definitely think that network of ideas, it's really hard, but I mean, you're looking at all of those, and actually you could say absolutely every single one of those really relates to mathematical thinking, because they're not going to see the connections and think about it if they're not using the correct manipulatives. If they're not taught to solve problems, are they thinking? Is it not, if it's not connected to their prior knowledge? If they're not working independently, again, I do worry a little bit about that over the last few weeks, and as children return to school, will they be used to working independently, or will they have been having one-to-one attention from their parents? Will they be motivated about mathematics, or will they be a little bit switched off? But I do think that that network of knowledge is really important, because that relies also on teacher subject knowledge, and that can be a tricky one, because if teachers don't see the connected ideas, then they're not going to be able to share that with the children in their modelling, their questioning, their discussions. So
I think that goes with representations as well, because I often talk about, say, nth term and an arithmetic sequence, and you can then show that as a graph, and for people to make the connections together, that n is your input, and x for your x-axis, y is your output, and the nth term, n equals 2 always, and where would it be on a graph? Then the representations links to independence, because if they have a chance to play with the manipulatives themselves and think about what they're doing, and if they move an algebra tile here and they turn your counter from red to yellow, why are they doing it? What's it therefore causing? What if I change it back? What's the same? What's different? The motivation is something, as I think you're absolutely right. Currently, it's obviously a major concern. But those tasks to challenge mathematics, question point 6 there, and that links back to what we were asking for depth. The structured interventions, well, bringing in the representation of manipulatives, are part of those scaffolds to provide that additional support. Of course, it goes into further details in the report as well. But you're right, a rich network of mathematical knowledge, making those connections between mathematical ideas, because we know about Vygotsky, zonal proximal development. If you are connecting, if you're teaching something new and you can link it to previous stuff, then they can grasp hold of it. And we know that how the brain works more and more with that. But also it's confidence in the classroom if you link it to previous stuff. So you're absolutely right. Mathematical knowledge and subject knowledge is really key. Can
I jump in there, Tom?
Please do.
So that network of mathematical knowledge, we've at Key Stage 5, we've had to really focus on that so much more since the A-level changes, because we've had to link all the Key Stage 4 stuff with Key Stage 5 learning. And we found that if students are unable to do that, they really struggle at Key Stage 5. And so we've really promoted making that kind of network in maths across Key Stage 4 and Key Stage 5. So I'd argue that those statements there are even more important now at Key Stage 4 and Key Stage 5 as well. So it's something which is, as A-level teachers, we've had to really address in our teaching.
That's interesting, because I suppose it's the same thing about being performance and actually whether we're building mathematicians or not. Because A-level mathematicians, are enough people choosing it? Are we building them to have the skills to do their own thinking themselves? And that responsibility, as you said, Helen, earlier on, really does start from the very beginning. It doesn't start from year 7. Anyone thinks that is ludicrous.
Do you want me to whisk you from A-level to early years and give you an example?
Bring it. Love it. We'd love that.
Right, if I go back and share again.
Brilliant.
See if I get this a little bit more.
See, you're more fluent at it through practice there, Helen. It was much quicker.
One of the key things I noticed when I went to Shanghai was their very, very young pupils were so quick at noticing things, really, really quick. They noticed patterns and relationships with numbers. And I realised that had to start before they started looking at numbers and before they got to Key Stage 2 or Key Stage 3. And I realised that actually when I looked at children more in this country, they've got more and more sort of passive and waiting for people to tell them things, and less actually noticing. I think just walking down the road, it's been quite nice the last few weeks. Hopefully people have noticed a lot more, noticed what they hear, noticed what they see. But asking children, what do you notice? Not going straight into, well, you know, find the answer to this. And then listening to their responses. Now, early years are usually really fantastic at doing this. Young children are really great, but sometimes that can get squashed out of them. So those early ideas, you know, parents can get involved in this as well, just noticing patterns and relationships and giving children the opportunity to talk about them, you know, simple sort of questions like this, where they can see things and they can talk about it. There's no right or wrong answer. There's lots to do, you know, which one's the odd one out there, or which two are connected, or, you know, anything. There's no right or wrong answer to it. Listening to the responses. Really, really important. I got into which one is the odd one out. So that website's quite useful, isn't it?
Yes.
For children to make those connections between the ideas that you show them. Now, this is an example of a child from reception, just doing some kind of general fact fluency work, you know, using subitizing, using the image of the tens frame. But when, you know, a 4-year-old child, you know, and you ask them, well, what can you see? And they turn around and give you an answer like that, and they're so young, you can see there's the start of something quite interesting going on there, isn't there? They're not just telling you, well, it's 7, or, you know, a straight answer. They're going a little bit further, and I think that's key, that you give children the opportunity to do that when they're really young, and give them the language and give them the support to be able to do that.
Some of the things you've just been saying about noticing stuff, and for some reason I can't get the movie Last Christmas out of my head. Not only because I'm a Wham fan, but also in the character, and I won't give anything about, I won't spoil it, but the main character is being told just to put their phone away, and suddenly they see stuff in the city they've never seen before, and they see the bright lights, they see the statues, and it's so true. And I'm terrible with my phone, I'm awful. But of course, if we've encouraged the same with children, not to look around and just see about what's there. Now, you mentioned which one doesn't belong, and I think we should probably get that website up, because it might not be one that people have thought about. And I like what you're saying there about, so I'll share that, so I can do that.
Yeah. Do you want me to? You all right sharing that? Yeah.
Yeah, so hopefully you can see it's an American website, but what you said was really important. There's no right answer. And I want to do a session on my resourceful series about the goal-free problems, because it takes away that anxiety. And the answer is just the beginning. But if there's no answer to find, no right or wrong answer, there's no anxiety. It's just, well, what do you see? What you see, as we would always be in, what's that program? Catchphrase.
Yes.
So let's do the random one. Let's go for shapes. So looking at just that top left one there, is this orange? Is that orange? I'm colorblind, so I get that wrong.
Yeah.
So what's the same? What's different? Well, one of them's coloured in. Okay. One that, in fact, you might say 3 of them are coloured white. 3 of them have 3 sides, but 1 doesn't. I don't know. That's just 2 answers straight away, but the answers they come up with.
I think it opens up their thinking to you, doesn't it?
Yeah.
It's nice. It's non-threatening. But actually, the responses from that and the way you can probe it really do tell you what's going on inside of their brains, and then you know where to go from that. I love these questions. They're really great.
There's certainly with shapes, there's so much to describe what's going on as well. And so for all ages, I think there's all sorts in here. But again, ones that belong, nice starter activity for just discussion in the classroom if you're trying to get the right mathematical language being used. Really, really nice website. Okay, I've unshared screen. I didn't mean to, because I wanted to go back to some of the stuff I prepared for today. Now, again, in fact, let's go back to this screen, sorry. The EEF document, if you haven't downloaded this in your schools, I really do encourage it. Improving Maths in Key Stage 2 and 3. And what they've also done now is made a kind of RAG report for you, so you can judge your school and say where you are, what's our focus area going to be, which is a really important thing for when you are leading maths.
It's great for action planning, that is, isn't it? It's really good.
Absolutely spot on. So, of course, it's all about mathematical thinking. And what does it mean, therefore, to think mathematically? And something you used Mason, earlier on, didn't you? What if I did this? What happens if I change that? And this slide here from, I think, is that the same document you used earlier on? I'm not sure it was. Questions and prompts for mathematical thinking. I'm going to suggest we just give it 10 seconds of allowing people to read that and me not talking over it. I don't know how many seconds that was, but I like the bottom left in particular. I always have, actually. If I alter something, what effect does that have?
Yeah.
If the answer is similar, pardon me, if this is the answer to a similar question, what was the question? Really nice to be able to create your own those ones when you just give an answer, what was the question? What must be added to make this complete on the top line there? Give me more examples. So we've got a few more examples of these kind of activities. But look at that. You could easily just print that and put it on every mathematics desk. And suddenly you've got structures to real mathematical thinking questions being delivered by the teacher. All the pupils? I don't know. Have you come across this very often, Helen?
Yeah, and I'll tell you another resource. I don't know, have you got it to share, or I can share it, is the progression maps with reasoning from the NCETM.
You could share that. I will stop share. That would be good to see.
I can share that with you.
I'm intending to do, as part of the resourceful series of where we're sharing all these resources online, I know you and I spoke about doing an NCTM session, talking through the website. So this might be delving into it at one.
Yeah, that might be quite useful.
Yeah,
the NCETM have started, Enrich do a lot on questioning, and there's some really good reading in there. And then what the NCETM have done is they've created some progression maps. Can you see that now?
Yes, you can.
They've created progression maps using those kind of question stems that originally came through Enrich. And I find these really, really useful, because if you actually, there's one of these for every area of mathematics. And actually, if you look at those, they have those same kind of questions, and for every topic in maths, for every year group. So if teachers start using these, what happens is they get used to that style of questioning. And that can go beyond your maths lesson. You know, you can use those questions in science and in literacy and things like that. Something that I did with one of my work group was we used these questions and we tried them out in different ways with children. So we took some of the questions from there, we turned them into sort of presented them in this way and started lessons with them, or used them as little concept maps at various points during a lesson. There are also some really good questions used in the mastery assessment booklets.
They're really good.
So again, those have got sort of similar examples in there. So yeah, I just think sometimes teachers can get a little bit overwhelmed when you're talking about, you know, questioning, and I find if you focus on one question style at a time and give them a few examples to get them up and going, and then build it, and over time you get teachers that are a lot more confident with asking questions. And again, it might start in the maths lesson, but it tends to go beyond, and it gets children thinking beyond just in maths.
Do you think that's something that's come up a number of times? Certainly when I was speaking with Robert Koplinski on Open Middle, he said about preparing before the lesson. And you can't always prepare for all the answers you're going to come with, because some of this is going to be a little bit scary to teachers who don't feel they have the right subject knowledge. But I suppose the only way to a certain degree we're going to learn it by doing. And if you are worried about going into an activity with pupils where you're worried what response is, then my thing I encourage absolutely is collaboration with your department. What have you done in the past? How is that? What did the pupils come up with? So you go in a little bit more armed and prepared, because if you aren't ready for the responses and you're nervous about it, then that's where I think people will be scared of doing these kind of activities, as opposed to just giving me, here's 10 questions, get on with it.
I think one of the easy ways of starting is the way your lesson actually starts. If I just share again sort of quickly, if you start an actual lesson, I think years ago when I trained to teach, we were taught to start a lesson by telling children the learning objective and the success criteria. Having them, you know, primary children sat on the floor while you showed them what to do. Well, actually, if we move away from that, get them off the floor and start a lesson with an actual problem where they're exploring, where they're feeling, where they're moving things around on their tables, not just drawing pictures, but moving things, talking to their partners about it. That's where you start to get the thinking going. So I think starting a lesson with a problem can be really, really beneficial. And I think that's something that primary schools, working with the maths subs in particular, have started to look at that. How do I start children off with a problem? Throw it out. I can assess what's going on. I can assess what they know. Some of the enriched problems like this one are really, really great for that. Just getting that feeling of, I want you to think, I want you to really, really think hard about this from the beginning. It's not about the answer. You know, even some of the things for home learning, that can, you know, get children thinking, just the way you present things and let them explore things.
Could you bounce back about 3 or 4 slides, Ellen? I think it had 3 to keep going, and I'll tell you when to stop. There was one I just wanted to pick up on. So that'll do. Either of these ones is fantastic. Look at what you've done at the bottom, because you've got the question, how many donuts does some have now? That's one thing that you might say is closed. It could be answered, but show it, explain it, record it is going to challenge the pupils to really be reasoning and think mathematically, as opposed to just here's the question, because you could argue very quickly that the answer is, let me check, Sam had 4, Sam has 6. But showing it, explaining it. Now recording it, can we talk a little bit about journaling?
We can, yeah. If I could actually probably find an example in here of journals. Journaling is really, really important to get children to think mathematically and share their thinking. What I would say possibly before I go into journals is, if I can, is just to talk about the language, because representation of the structure, but also the language is really, really important.
Yeah.
Children haven't got the language to talk about it in the lesson. They're not going to be able to write about it in their journal. So I do think having something there around language and seeing that idea, that link, that actually, yeah, it is really, when I was at the beginning of my career, I worked with hearing impaired children. And if you've got someone that's been deaf from birth and you try and work out how they think without ever having heard words, it really gets you, you know, thinking about how learning can be difficult. If they don't have the words for it, it's hard to think about it. And maths words can be confusing. Yeah. Maths words have different uses outside of the maths lesson. So I do think thinking about the vocabulary is really, really important. The other thing, when you come to journals, I can show you an example. Getting children to think really, really hard about the mathematics, getting them not to be afraid of it. So again, something that we've learned is exploring the problem solving. So, you know, this is a simple problem I've done with some children and adults in training, getting them to do it with bar modelling. So these before and after problems can be quite tricky. That kind of problem a few years ago perhaps would have thrown children off if they were trying to rucksack it or something like that. But when I started to use this problem with adults a few years ago, and I realised how tricky they were finding it, I started to use this as one I could try with children to see where their thinking was at. Now, some children if you see on the one side of the screen there, on the squared paper, where you've got a load of numbers and you've got a table coming through, that's a year 6 child who knew a procedure. And just by seeing what they've recorded in their book, you could see that they were trying to follow a procedure, but it took them an awful long time. Yeah. Whereas the child on the other side is a younger child in year 4 who actually came to the answer a lot quicker and was able to talk about it and explain it. Whereas this was from a couple of SEN children in year 2, who actually that same question, although it was adapted just to say instead of 9 times as many, it was 5 times as many, because these children hadn't actually been taught multiplication at that point in the year. And that's kind of very basic journaling, where they were putting down some ideas and explaining it and drawing pictures of it. Now that's children that hadn't been introduced to journaling. So they hadn't gone through the whole, sort of journey, but they were just encouraged, draw a picture, tell me about it, on paper, record what you're thinking. That's kind of an idea of journaling. I could show you another example of journaling. Lots of opportunities in a lesson. If throughout a lesson, children are actually sharing ideas and critiquing ideas, you will find that they will start to do that when it comes to their journaling. So again, getting children to notice. This links with the it links with the EEF again about the idea of motivation. Getting children to think about their own learning is really, really important. So you can see an example of journaling there, where the children have not just got the answer, not just showing that they understand some vocabulary, but they're actually showing that concept in more than one way. And then they're considering, they're evaluating the most efficient method. So I know different ways of doing this, but the most efficient method is what I'm going to think about.
And I take that to secondary as well. Leaving that on screen, you mentioned about multiple representations. I noticed on Twitter yesterday, someone was talking about how they introduce expressions. And some people said they'd use algebra tiles, some using bar models. But actually, which do you think, by teaching them the multiple ways of doing it, it's then for the pupils to decide which is the most efficient, which is the right strategy for me to use today.
Yes.
And I think bar modeling worked very nicely, but I use algebra tiles. I try to use algebra tiles a lot. But again, if the pupil's choosing which is the better representation, then they're having to think about which makes more sense, which is more efficient, which will explain my answer better. And I think that's actually really nice with your bar models there on the bottom right-hand side behind those. I know you put there it is. You've got your abstract form, you've got the bar model, you've got your partitioning there, you've got Dean's. That's just really nice that they understand it in all these different ways. And that's real fluency. And again, that's where the 5 big ideas all link together. So really important, not just to think, right, we're going to focus on bar modeling this year, the secondary teachers, actually, all of them, as many as you can, because then pupils can
look at those different and seeing the connection between them is really, really important. Yeah. Again, getting children to notice, really, really important. And so again, you know, with journaling, there's different types of journaling, and investigative journaling really gets them to notice and make connections and explain what they've noticed. So again, there's another example of a journal there, but that comes from them doing it within the lesson. Sort of that idea of sharing ideas within the lesson with everybody, that they then can have a go at recording in their books. It may even involve giving them some sentence prompts to get them going, which can be really, really useful. I love seeing when they say, I noticed, or because, that's when you really start to see what's going on. There's another example of that's a year 3 child that's been looking at multiplication, and they've been looking at scaling there, but you can really see that they're trying to connect ideas there, and you can see it's a lot more than just being able to do, well, I know what 7 times 2 is 14, right, move on, let's do another half a dozen of those. They're making those connections, I know, and I'm connecting it, and you can see that coming through in the journal.
Let's make some of those connections. I'm going to steal the screen back if I may.
Yeah.
It seems I can't. There it is. Stop. Yeah, I can steal it back. I've got a few things about making connections. I think it's really important. Really nice examples. In fact, was the next slide. Steve Lomax, I talk about him a lot. Gets involved with Can Do Maths, and look at this as an activity with making connections between mathematics. Just one maths fact there in the top left-hand corner. 7 times 8 is 56. But if I know that, I also know that 8 times 7 is 56. I also know that 56 divided by 7 equals 8. I know that 56 divided by 8 equals 7. I know that 8 is a factor of 56. I know 7 is a factor of 56. I know, and look at that language here, factor of, because children get confused with the words factors and multiples. But if we've shown them in these different ways, there's no reason why that should happen.
Yeah.
The importance of that language, absolutely right, Helen. And I'm presenting at Maths Conf tomorrow, my Speak Like a Mathematician talk, because I'm really keen on that, and that we're all consistent. And that doesn't just go primary, secondary. And we do have cynical people in every profession, but they're like, oh, well, everyone's got to do it the same. Well, start at home, start in your department, start in your school. Is everybody speaking the same language? So when sadly, we don't get to have the same teacher in year 7, 8, 9, 10, 11 very often. And that would be exactly the same in primary. If they're saying different things from different years, that's a real shame. But look at these facts here. Everything on that.
It's brilliant, isn't it? Yeah.
Superb
If you look at the tens frame behind me, you might look at that, especially being secondary, and just think, well, that's about 7 and 3 and being 10. But actually, children in Key Stage 1 learning those facts, then getting to connect it to actually, well, that's also about 70 and 30. It's also about 700 and 300. It's also about 7/10 and 3/10. It's all those connected ideas, but can come from the one resource and the one fact that they know. But it's making those connections really important in the classroom.
I think that's absolutely right. I want to point out that this is. I know there's actually been a bit more of an update on this research in the last month or so, and I really need to sit down and watch it. But the big things being said: derived facts make a big difference to our pupils. Students rarely use derived facts because teachers do not teach them explicitly. Going back to this is derived facts. It's a great example of just 7 times 8 equals 56. Therefore,
do you think that's because when the curriculum changed, using derived facts used to be a specific objective, didn't it, on the curriculum previously?
Yeah.
I don't think I've seen the word derived facts on the national curriculum in primary. It is, it's hidden in there. I think the actual term, I don't know whether that's made a difference.
Well, the words making connections are on there somewhere, but what does that mean necessarily? We were explaining that a little bit this morning. But again, teachers believe that derived facts are obvious, but they're not, and students aren't familiar with them. Now, if you are interested, do look up this research because they published it in the last month or so. This was an investigation during the research the last couple of years. I think there's an hour and a half Zoom presentation with it as well, if you'd rather watch the Hodgin et al. Talking about it, but it's something I really must get round to watching. In one of the previous sessions, someone suggested this, and it comes from an ATM Thinkers document, and it's a really quick, nice exercise, so we'll do a version of it. Give me an example of a fraction that's equivalent to 2/3, and I think you'd get your children saying 4/6, you get your children saying 20 over 30. The smarter ones, in inverted commas, I'm being very careful there with my language, might start going -2 and -3. But then peculiar examples would be a -2 over -3, maybe 2 pi over 3 pi. And therefore, we're actually generalizing. We're saying it's 2 lots of something over 3 lots of something. 2 units over 3 units, 2 units divided by 3 units. It's quite a nice activity. In fact, I know I've got that on screen. So let me just grab that from the ATM Thinkers book. So pointing toward generality. And again, generality is in the national curriculum. It's AO2. And having that generality helps us, of course, go into the assessment objective 3 into problem solving. But the examples there, 2 billion over 3 billion. And the pupils love being able to do these massive numbers. Anytime there's an opportunity to say a big number, 1 billion, 2 billion. But it comes to the very basic fact that 2/3 is 2 lots of something divided by 3 lots of something.
Yeah.
It's a nice little activity, that one. So that's from ATM Thinkers. I'm trying to think what we've got time for. That was some of the Enrich wording there about how to think mathematically. This I really like. I'm going to put this full on screen. Again from Can Do Maths, from a paper, I've never known how to pronounce the name, I'm not going to lie, Quaco et al. But I've been reading that recently for a project I'm doing. And Colin the caribou, I didn't know a caribou was an animal, I like to learn new things. But look at all the mathematical behaviors we want from pupils. And you said today about behaviors of pupils. So I think this is a really interesting document. I've linked to it on my website as well. Mathematicians like to experiment. They pattern sniff. They tinker with stuff. They change stuff. Conjecture there on the middle, on the left-hand side. Actually, I've just done an example of something that I'm always quite keen on in pupils. Do you know when the kids say there? And I've just said middle row on the left. Just using that language, be able to explain where it is.
Making them, pulling it out of them, isn't it?
Yeah. But look at that, visualize. And there's 8 organized habits of mind of mathematicians. It's a really nice document worth reading. If you don't embrace the Colin the caribou, then you should be embracing the habits of mind behind it. Always, sometimes, never questions. I've got myself a nice challenging one there for the Key Stage 4 teachers and beyond. But is this always true? And people have to justify it. And there's no problem with me using a calculator in these respects, actually, because it's not them testing that 3 to the power of 4, do they know it in their head? Actually, it's them trying to justify the general statement. So always, sometimes, never questions are always beautiful things to do in the classroom. I saw this on Twitter yesterday, and I immediately thought I needed to share this question. So thank you to Lisa Wilson for letting me share this. Now, I see these questions a bit more in Key Stage 2 than I do in Key Stage 3 upwards. I'm in particular looking at number 2 here. Use the fact that, and these do appear in SATs questions, don't they?
They do. They also appear in those NCETM, those progression maps and some of the NCETM materials, that style of question. And those are ones that children very often find really hard. If you haven't done enough of that in school.
Sorry to talk over you there, Helen. This example I was almost talking a little bit about with Joe Morgan on Wednesday evening. Use the fact that. Now, for prime factors, I had a pupil who did all the work on the prime factor tree. Not actually, wasn't my pupil, it was an exam I was marking. And they'd done the prime factor tree, and you think, oh, they know their topic. But when you look at the answer line, they added all the prime factors together. So they didn't have a clue that factors are to do with multiplication. And so looking at that question there, how much you have to understand the topic, use the fact that 84 equals 2 squared times 3 times 7. Well, if that's half the size of it, so all it is one factor, 2 being removed. So 42 must be 2 times 3 times 7. To answer these questions, you have to understand the topic. You could get away with answering these just by the procedure. But it does say, using the questions, start by writing 10 and use them. So again, what Lisa's clearly done in her classroom is what you said earlier on, working on the problems, connecting them, not working through them. But what a beautiful example of making sure you understand the concept of what's going on. I just thought it was a really nice slide, and I wanted to make sure I shared that today. And again, another reason why I big up Twitter. When people aren't being negative, there's so much positivity being shared. If you don't follow Helen, you should be, because Helen finds maths everywhere in the world, in everything she sees, and of course she's right. And if she's not sharing that, she's sharing cats, which is also great.
Yes, yeah, cats and maths. Flopsy, my maths cat. Actually, I took to reading a book this week that helped me to give me an insight as to why I'm a little bit crazy and why some people don't like me. I often think about thinking as a mathematician, and we've been talking about thinking as a mathematician, but I've been reading a book about physics, and it talks about thinking as a physicist. And I thought, what does that mean? And then I realised, I'll share my screen very quickly and you can see the book. Thinking as a physicist, this has been my problem all my life. This is why I was never very popular at school with my teachers. But this is what it means, that questioning everything, never just accepting things at face value, not believing things, always asking, well, why? Why is that so? How does that work? Looking at the evidence, knowing that you're going to make mistakes. You know, scientists experiment and they make mistakes, don't they? And actually knowing, I think with a lot of the action research I've been doing with Teaching for Mastery over the last few years, what I thought a few years ago, I think very differently now. Lessons I taught a couple of years ago, I would teach very differently now. But I think thinking like a physicist, thinking like a scientist, thinking like a mathematician, it's always been, asking the questions, isn't it? Asking why and how. And I think sometimes we don't do that with children. And I think that's quite, that is a shame if we don't do that enough.
You know, connecting that with the real world, when you're saying about don't just take everything on face value, I don't want to convey my almost anger that when I am on Twitter and on Facebook and everything else, and people share facts without even giving it a second thought. I've just started reading a Dave Gorman book about too much information, and he gave an example, a nice maths one, saying that in this month is a special month because Saturday and Sunday and Monday will appear 5 times this month. This won't happen again for another 840 years or something, which is absolute nonsense. But someone will look at it 31 days and think, well, that's odd, more than 4 times, and they'll believe it, share it. And I'm not going to go down the political, but we know that people share stuff without even thinking about it. and that's really, really frustrating. I'm told you're sharing your screen. Just had a little message sent to me. So is this something you're trying to share at the moment, or is it?
Sorry, I've stopped sharing.
Well, we are coming close to the hour, and I cannot believe how quick that's gone, Helen. So what I'm going to do is just quickly go share my screen and go to the key ideas again that the NCETM put out there. I mentioned them at the start, and maybe you just reflect on them again to finish this hour. Really enjoyed that. Central to deep and sustainable learning of mathematics, i.e., I think that connection there, that example I did with the prime factors, you have to think about each question. If I know one thing, answer the next question. And we've talked about, and again, I'm going to hold it up because I love this. I love this. We are making the children think. Memory is the residue of thought. Let's see what else we've got. We had receive passively. We don't want them received passively, pardon me. Worked on. There it is. As you said, worked on, worked through. Worked on by the student, reasoned with, thought about, discussed. A quiet classroom is a suspicious classroom. Mathematical thinking involves looking for pattern in order to discern structure. Now that's interesting because we talked about the multiple representations as well. And there we're going to see the structure performed in different ways, presented in different ways, and therefore and also looking for pattern. You said about noticing things in this hour. And again, that's putting your phone down occasionally and noticing something around the world around you. I mean, I'm in my office shed, and there's lots of parallel lines going on. There's lots of consistency. There's loads of patterns just looking around the room. Looking for relationships and connecting ideas. Actually, those two they're not looking for the answer. And what you said earlier on, taking away the answer and just allowing pupils to think about, well, what could be going on? Let's explain that. I'm not worried about getting it right. The answer is just the beginning. I'm not worried about getting it right. I'm just saying what I see. I notice, I conjecture, I then discuss. And then I reason logically. I explain, conjecture, and prove. And if they can do the proving, that's a mathematical skill, but that comes with everything beforehand, doesn't it?
Yeah, absolutely. And I think that mathematical thinking has to start with the adults in the classroom as well. If the adults aren't, I think in literacy, they talk a lot about talking as a reader, talking as a writer. Are we talking as a mathematician when we're talking in classrooms, when we are modelling? Are we actually talking our thought processes through out loud with the children and doing it in real time? I think that's very important as well to get children to think.
I think that's, I'm going to end it there, I think, because I'd like to end with these, but a reminder, and I'm going to make sure the 5 big ideas are put back on screen. We'll carry on this session on Friday mornings. So next week, you get a week off, Helen, but I know you're back the week afterwards. Is it always true that practice makes permanent? Faye returns to look at the third of the 5 big ideas. If you weren't aware, I'm doing my resourceful series as well. And next Wednesday, mathspot.com. What a fabulous website for numerous resources, must be used in primary as well as secondary, surely, Helen, yeah?
Yeah, it's great, yeah.
Brilliant, so I can be joined by him. And then Resourceful 5, I don't know if it's my next slide. Oh, Resourceful 3, Resourceaholic, fantastic website. Open Middle, it was Steve Lomax who made me think about empty box problems. Go back and listen to this because empty box problems, what a great website that was. But also, and I'm so excited, Helen, Craig Barton's going to join me.
Oh, wow, brilliant.
It is brilliant. But I knew that hour would be great, Helen, because I knew we could just chat about that. Thank you so much for doing this. It's appreciated very much by me, but I'm sure by everybody watching this as well. And I will see you in a couple of weeks' time for the next.